All right, let's dive into a really fascinating story from the world of AI. It's a story about a model that was trained to do one specific job, but it kind of accidentally learned a completely different and way more powerful skill in the process. So let me just ask you this, because it sounds like a riddle, right? Can an AI that you train only to fix software bugs somehow get better at math? I mean, how could getting good at fixing messy, complicated code possibly make you better at something totally different, like mathematical reasoning? Well, that's the mystery we're going to unravel today. So here's the paradox laid out plain and simple. On one side, you've got the training. The AI was fed millions of real-world software bugs and their fixes, all scraped from GitHub. Messy stuff. On the other side, the surprise. The AI didn't just get good at fixing bugs. It actually improved its scores on things like math and logic puzzles. How on earth is that even possible? Okay, so first things first, let's really get a handle on the challenge here. What exactly were the researchers trying to get this AI to do in the first place? Fixing a bug in a real piece of software isn't like solving a neat little coding puzzle. Real-world code is this tangled web of old code, weird dependencies. It's just messy. To fix a bug, you have to understand all that context. You have to guess what side effects your fix might cause. And historically, that kind of complex contextual thinking has been incredibly hard for AI. So to measure if an AI could actually handle this mess, researchers built something called SWE-bench. And you should really think of this as the ultimate final exam for any AI that claims it can do real software engineering. It's not a simulation. It's a collection of actual, difficult, thorny problems pulled directly from real-world projects. Okay, so faced with this massive challenge, the researchers behind a new model called SWE-RL, well, they tried a completely different way of teaching it. They started with a dataset that is just mind-bogglingly huge. They curated the entire history of 4.6 million open-source projects on GitHub. And they weren't just looking at the finished code. No, they were looking at the whole journey. The bug reports, the back-and-forth discussions, the failed attempts, and of course, the final fixes that human developers came up with. And here is where the magic really happens. They used a technique called reinforcement learning. So the AI looks at a problem, it tries to fix it, and then it gets a score based on how close its attempt was to what the human developer actually did. It's this continuous feedback loop of try, fail, get a score, learn, and try again. It's all about pushing the AI to learn the process of solving the problem. Now, this is a huge departure from the old way of doing things. The standard method, called supervised fine-tuning, or SFT, is basically like giving a student the answer key to a test. They just memorize the answers, the specific patterns. But this reinforcement learning approach, that's like making the student actually solve the problems and rewarding them for figuring out the process. It builds a much more flexible, real problem-solving strategy. So, the big question. Did this whole new approach actually pay off? Well, the results, they were even better than anyone really expected. The final model, which they built on top of the really powerful open-source Llama 3 model, managed to solve a whopping 41% of the issues on that super tough SWE-bench benchmark. Now, for problems this complex, a score like that is a massive leap forward. And to put that 41% into perspective for you, it means this open source model is now performing in the same league as the giant closed source proprietary models like OpenAI's GPT-4o. It was proof that this new training method was creating a seriously capable AI software engineer. But you know what? The most incredible part wasn't just the score. It was how the model was thinking. This right here is an actual quote from the AI's internal monologue as it worked. You can literally see it reasoning, questioning itself, and then having a genuine aha moment, just like a human developer would. It's wild. And that is the key right there. See, by forcing the AI to grapple with these messy, complex, real-world problems, it didn't just learn how to code better. It develops these higher-level reasoning skills. It learned how to self-reflect, how to try different angles on a problem, and how to break big challenges down into smaller, manageable chunks. So this brings us right back to that bizarre question from the beginning. What happens when an AI develops these powerful, general-purpose reasoning skills? Do they actually work on anything else? So, naturally, the researchers had to know. They took their specialized bug-fixing AI and they threw a whole battery of completely different tests at it, stuff in math, general logic, and function coding, just to see if these newfound reasoning skills would actually transfer. And the results were, frankly, stunning. Just look at this. Take math reasoning. The standard Llama 3 model scored about 63%. The model that just memorized the answer key, it actually got worse, dropping down to 54%. But the SWE-RL model, the one that learned the problem-solving process, it jumped all the way up to almost 74%. And you see this pattern pretty much across the board. The memorizer often got worse, but the reasoner got better. So here it is, the big takeaway. Forcing an AI to just memorize answers for one specific task actually made it dumber at other things. It narrowed its skills. But rewarding it for struggling through the process of solving complex real-world problems, that didn't just teach it one skill, it taught it the universal skill of how to reason. Now, this is way more than just a cool academic experiment. This has really profound implications for the entire future of artificial intelligence. What this research is really giving us is a potential new blueprint, a new recipe for building smarter, more general AI. The idea is, instead of just feeding them endless facts to memorize, we can give them complex, messy, real-world problem sets and reward them for learning the fundamental principles of reasoning all by themselves. So, if you're going to remember anything from this, here are the key insights. First, that messy, real-world data is incredibly valuable for teaching. Second, that focusing on the process of how humans solve problems can unlock true reasoning in an AI. And finally, and maybe most importantly, this idea isn't just limited to code. And that just leaves us with this one final, really powerful question. If we can teach an AI to reason by having it study the entire history of human problem solving and software development, what could we possibly unlock by having it learn from the complete history of scientific discovery, or legal arguments, or even artistic creation? The possibilities are, well, they're truly fascinating to think about.